Okay, here's an Alex table from the homework, and what is being asked in this table is that we assign oxidation states to the highlighted atom, so the one that's in red here. Alright, so let's do oxygen and H2O. So I have H2O, and when I assign oxidation states I usually put them above. And so oxygen in this case, and as we learned in class, always going to be a -2. Very rarely is it not. So oxygen is a -2. So in Alex I would write -2. Alright, our next one is carbon dioxide. Then we're going to focus on the carbon. So we have CO2. Well, each of the oxygens is a -2. And so that is the oxidation state. But for counting purposes, what I do is I take a 2 times a -2 and I just write up in really small. I know that that's a -4 oxidation on that oxygen. The oxidation state's a -2, but just for counting, I'm going to put -4 up there. Well, since this is a neutral compound, carbon dioxide is, I have to get the oxidation states to add up to 0. And the only way I can do that is to assign carbon an oxidation state of +4. My counting up there goes to 0, and so the oxidation state of carbon is, I'd write in Alex, +4. Alright, let's look at ammonia right here. Ammonia is NH3. Each of the hydrogens, is a +1. Hydrogen is a +1. So when for my counting purpose, I go 3 times a +1, just write real small up here, +3. 3 times a +1 is a +3. And so I need to get those oxidation states to add up to 0. So the only way that can happen is if each of the nitrogens, which there's only one, is a -3. So a -3. And so for counting purpose, 1 times -3 is -3. Do those add up to 0? They do. This is a neutral compound, and so for nitrogen it is a -3. Now let's look at CHCl3. Okay, when I look at that, I'm trying to get for that carbon right there. Well, the chlorines in this case are all going to be a -1. Okay, so chlorine's a -1. I can get that from the periodic table. So for counting purposes, I'm going to do 3 times a -1, so that is a -3. All the oxidation states, since this is a neutral compound, need to add up to -3. Now I'm going to tackle that hydrogen next. So the hydrogen is going to be a +1. Hydrogen is a +1, so for counting purposes, 1 times +1 is a +1. Now I need to get all of these to add up to 0. I have one carbon, so in order to get everything to add up to 0 in my accounting states up here, then the only way that can be is if carbon is a +2. 1 times 2 is a +2. When I add all those up, the total oxidation state is 0 of the entire compound. And so for carbon it is a +2. You submit those to Alex and you should be able to get that one right.